And we're live.
Hello, hello.
Hi,
Hello.
everybody.
Hello.
Thank you all so much for joining. How's everybody doing today?
Doing all right, thanks. How are you?
Well enough. Well, I guess we're still in an epidemic, so, holding on.
hmm Yep. How are you, Ramon?
I'm good, thank you. Yes, having a relatively relaxed day, taking it easy, and yeah, doing the best I can.
Oh, we're gonna get a really chill talk about some extensible WebAssembly today, I guess.
Woo.
I'm very excited. If I may, let me run down how this is going to go today and sort of outline what my role is going to be, because you all might be thinking, I thought this was just Flaki and Laura. What's he doing here? Um,
Get
I'm
and
sure
out of
nobody is thinking that.
here.
so my role today is to sort of hang back, help with some moderation, do some screen sharing every now and then to put up some links, and yeah, learn a lot. I'm gonna be in the chat as well, so if y'all have any questions or something, feel free to chime that in. And yeah, so if you've got any questions, I'll be popping in every now and then strategically so as to not interrupt Flaki and Laura. And yeah, bring your comments and questions over. So please, this is an open conversation, folks. Join in, and yeah, I'll leave you all to it.
I did tell people on Twitter to, if they wanted to fight me on my notion of like WebAssembly extensibility being one of the coolest use cases, they could fight me in the comments. So that's, yeah, we needed to bring in somebody to handle
I'll be the proxy. I'll be the punching bag.
that.
All right. Well, best of luck, and looking forward to learning lots. See you around.
All
All right.
right.
So I think well, I know that you know tons more about this than I do. 'Cause you've been in this ecosystem for kind of a while, right? Like I think I was only starting to really appreciate that like a week ago that you've been at this for a while. Is that right?
I mean, I can't say I have not. Like I've been really intrigued about like WebAssembly for a long time, and like I really don't want to like kind of digress. Like we did the last time in Remote like that, we kind of really didn't make it like all over to. We kind of talked a bit too much. I'm very happy to talk about like the history of WebAssembly and like how I got into it to the point of like that being counterproductive towards discussing more important matters. But yeah, I've been spending a lot of time in WebAssembly. I've been fascinated with just the technology, like
hmm
being there, seeing it evolve was like like giving like enormous context or like extra context to like how I see the technology today, and like I feel that's like an enormous like kind of gift or like kind of privilege to have
hmm
seen like kind of WebAssembly evolve to what it is today. So yeah, I have a lot of excitement about a lot of things about WebAssembly, and like a lot of that stems from like just having seen it like kind of go from like budding technology into kind of people discovering it all over the place, and like giant $1 million startups being like founded on like kind of
Right.
taking
Yeah.
that like next level.
Yeah, yeah. Whereas I only heard of WebAssembly for the first time 3 months ago. So yeah, I
Which is
have
like
little fledgling understanding.
no, but like that's
This will be
exactly what I
great.
was gonna. No, but that's what I was gonna is to say is like it's really interesting also to see how your understanding has evolved over the past weeks and
Mhm.
months, and like I think you're catching up real fast, so you might have not have the context of like the early days of WebAssembly, but like
Mm,
like the current days of WebAssembly, you're pretty like this is something I used to tell people a lot when I used to teach people front end development and like kind of boot camp sort of things as well. Is like everybody is like, oh, you can't teach like web development in like 6 weeks or 6 months or
mm,
whatever time. And I was like, you can teach a lot of web development in 6 weeks or 6 months, because you don't have to give them the entire context that exists in your head, because that includes
Mhm.
Opera browser bugs
Right.
from 10 years ago, which is like they don't need to know that. Like they need to know how to kind of develop for the web today, and like the
Mhm.
modern web and like a lot of data technologies, and also like just kind of give them enough context so they can find their way afterwards. And like
Mhm.
this is kind of how I feel about WebAssembly. It's like you don't have to know, like we kind of digressed last time. I was
Mhm.
to the like JIT compilers and whatnot, which is like interesting. Like maybe like you could even say that it's an important aspect of like
I
WebAssembly,
thought
but you
so.
really don't have to know it just to understand like some of the like key components that kind of make WebAssembly kind of viable, or like more like usable, like you kind of you can use like JIT compiler knowledge to understand what makes WebAssembly kind of viable, or like what brought it like to kind of the scene. But like to be able
Mhm.
to take advantage of it, you really don't need to
Mhm.
know like how
Yeah,
JIT compilers
that makes
work or
sense.
something like that.
Yeah. So how do you want to start today?
Gonna tweet us that we are live, and that's out. I guess so. Well, let me. How do you foreshadow something
Mhm.
that's coming to the suborbital blog? So if people are going to be, actually, there are like multiple things coming to the suborbital blog. So there's a lot
Oh,
of
it's happened.
foreshadowing.
Yeah.
But like, let me actually, before you start interviewing me about my vast knowledge of WebAssembly ecosystem, you had a chance to chat to somebody recently
I did.
on like WebAssembly extensibility.
Mhm.
Like, would you like? I was wondering, like, I've read like some of the things that are going to go into the secret blog post that is going to come to the suborbital blog soon. But maybe you want to. I don't know. I'm just curious, like, how was that experience? Like, how was that discussion? And like, how did you like kind of feel like getting up and close with like one of the companies using like WebAssembly extensibility to the fullest today, right? It's like in production.
Yeah, yeah. I mean, it definitely broadened, or maybe deepened would be a better word. Deepened
Mhm.
my understanding of how WebAssembly, because that was something that I felt like was really sort of missing from my life until maybe a week ago, where like, okay, so WebAssembly sounds awesome. What the hell can you do with it? Like you can do everything with it. Not quite. You can do these, and it was like this this veil, I suppose. It was just like this, or fog, like I know there's stuff in there, but I just can't quite get to what the stuff is. And that was sort of one of the first like aha light bulb moments for me of like what this could be for, or in fact is currently for, not just could be. um
Mm.
this is a
I think
realized potential, not a
no,
theoretical
I
potential.
think I think it's fine to share like like the company and like the product that you'll be talking to, because it's
Oh,
a
okay, yeah.
really fine example.
Okay. Yeah, so I
Just
spoke
to give kind
to
of people a bit more context.
Sure. I spoke to Saul Cabrera at Shopify, and they are using WebAssembly to extend their ecosystem to their um, client companies, I guess maybe you would put it. So my understanding is that companies would use Shopify as their web front, and that this way they can choose, instead of having to code all of their bits and pieces from scratch and then sort of push it to Shopify. Shopify can provide them with almost like plugins, so you can just sort of grab little bits and pieces of pre-compiled WebAssembly, and that has these big advantages because it is pre-compiled, and so it's really fast, and it's also quite secure because of some inherent properties of WebAssembly, like sandboxing, and so on. So that makes it easier, faster and more secure for companies to deploy their apps through Shopify?
Yeah, this is something I find really fascinating, and it's actually quite old. I think it's the WebAssembly Summit last year, like WebAssembly Summit 2021, actually had a talk from Shopify. Maybe Ramon can look that up, like
Mm.
and share it with the chat. There's actually a talk where they actually like kind of go pretty deep into like we have been like so that was not the first WebAssembly Summit conference. Like that was second, third conference, and they were like, we have been talking about WebAssembly a lot, but like you know, this is like something that has been a game changer for Shopify, and that has actually not been able to like. There is a couple of things that WebAssembly makes better, and there's a couple of things that WebAssembly like kind of improves on. But
Mhm.
this was like much like Suborbital, like recent blog post. Connor said the same. It's like we couldn't have done this without like WebAssembly existing. It's like
Mhm.
essential to what we like kind of set out to do to have WebAssembly. Like this technology, if it didn't exist, like we wouldn't even have come up with this. And that
Mhm.
was sort of basically what Shopify would say is
Right.
like by being able to run these like sandbox WebAssembly modules in like our own infrastructure, which is what's happening here. Like them, it's like it's funny because they're basically they're using running their users code in their own infrastructure. And speaking of like, foreshadowing of future blog posts, we are going to be talking about that as well in the future.
Mhm.
But like this kind of like user defined functions idea of like giving your users like more like flexibility, more like kind of uh, like giving them more like power in what they can do in your systems. Like probably the easiest like kind of way to describe this is you've probably seen like you can use like a web mail system, like an email system, like
Mhm.
Gmail or something like that, and you can set up rules like if like an email arrives from this sender, like put it into that folder. And like
Uh-huh.
that sounds, and that, that's like the very basics of like a user defined function. Like you can like click that together in a user interface. But like, what if you wanted to like kind of run a more like complex algorithm, like that uses even like maybe external data sources or something like that. Yeah, and like that's kind of like taking it from like like just something that you are able to click together to like be something really flexible and really like powerful. Like give people the ability to basically write code to like run some sort of like business logic. And
Mhm.
so Shopify's use case is basically this: when they're like, we will let you do like run whatever complex logic you want to run to, for example, figure out, you know, what sort of pricing you want to give for a certain product, or like, like there are all these like options and abilities that like software like this already makes possible, like like kind of bulk pricing, and like if you order like X or more, it costs less, or like like there's a various like things about like figuring out like shipping costs and like multiple things that affect the kind of the pricing, and like various like aspects of like a shopping workflow. And they're
Mhm.
like it would be cool if you would have more like power around this, more than just what we could give you like with a user interface or something like that. And so that's kind of like this is what like the user defined function idea comes from, is like give people like the absolute flexibility. Like you kind of still, if you do some kind of offer some kind of scripting language, if you offer some kind of like user interface with like some logic and like gates, you're giving people kind of like an ability to describe like an algorithm but like basically giving people the full power of a programming language is what makes it possible for people to do like arbitrarily complex like solutions to a problem. But the problem with that is like how that used to work is like you would like have to run the code yourself. Like maybe like it would be like a webhook or something. Like Shopify would call out to like a web server that you run yourself, and that web server would run the code. Or like maybe it would be like something like a cloud function on like AWS or something like that. And like when that would do the thing, like it would reply back to Shopify as like, hey, this is the result of the complex calculation. But there is like multiple problems with that. Again, I don't want to really go super deep into that, but like and so the video explains that. But they were like, there's like problems with this of like sending this data, like some of Shopify's data, or even like the current information about the person who is doing the checkout into like an external server. And like what happens if like that got like kind of leaked like on the way there. What if your server has like kind of like an intruder, and like so you leak that data. Like Shopify doesn't really like cannot really know if a breach happened on your server while the data was like on your side. And like there's like all these like complex problems about like this thing. And like something very important that they also talk about is that the latency of this kind of in like uh of like this whole process of like sending something outside of Shopify and like bringing back some response has like a multitude of things can go wrong. Like what if your server is offline? What if your server is overloaded? Like they would have to
Mhm.
keep like pinging back and forth. What if your server is like on the other side of the planet? Like it's like there's all kinds of issues. And like like what if your server is slow and like there is a long time that like the latency of the calculation is going to be really like slow. And as we know, like in e-commerce, like like latencies are super important. And like you can absolutely lose like a percentage of your buyers and your traffic if you have like high latencies. Like Amazon, like
Right.
there's like a lot of anecdotes about this. And so they were like we really wanted something inside our system. We really wanted to have like full control over this. But
Mhm.
like the problem with that is like when you put it in your own infrastructure, then you have to figure out how to make sure that people absolutely cannot compromise that infrastructure.
Right.
Like run over, like take down your whole server because like somebody wrote
Mhm.
like a like a malicious plugin, or like
Mhm.
how if they can extract like some of this information. And like that's basically like the answer to their prayers, WebAssembly, the technology.
Yeah, yeah, that all makes a lot of sense. Um, yeah, and just again, it's so good to have this to sort of latch onto
Yeah.
as I mean, not the only possibility or possibility that's made possible by WebAssembly, but as sort of
Mhm.
my first one. It's just I'm kind of a limpet at the moment. I'm like, ah, okay, yes, I have a thing. I have an example.
No, yeah, I mean, it's really hard for WebAssembly to kind of find like really good like real life use cases. So
Yeah.
I can totally like not because like like we don't get to talk about them like, but it's kind of like a lot of different times it feels like that a lot of these use cases uh there's no one point, there's no one thing that WebAssembly does. It's like magic, right? It's like no
Hmm.
one silver bullet property about WebAssembly. Like you could say, sandboxing is an important thing about WebAssembly. And like, some people could come along and say, well, not WebAssembly is not the only thing you could sandbox this thing with. And they would be right? Like WebAssembly is not, like the first like technology that lets you like kind of like make the sandboxing happen.
Hmm.
But WebAssembly has also really good performance, and arbitrary programming languages could be used to target WebAssembly. Like it's like kind of agnostic of the programming language, and like that it's kind of platform agnostic in terms of like the runtime, or like where when it gets run, and like as long as it's compiled to WebAssembly, it kind of is like agnostic. And then all these properties coupled with like the sandboxing form this sort of like magic, synergy. Is that like that's something we have to do buzzword? So it's like synergies of these technologies that actually makes WebAssembly like what it is, and like like that kind of makes this like no-brainer technology, like the intersection of like all these properties used together like kind of make like a lot of sense.
Yeah. Yeah. Yeah, I mean, right. Okay. And so maybe we should also talk about, so you alluded to user-defined functions, like that's
Mm.
what, something that could if you're bringing those into your own infrastructure, then we potentially have some threats that we need to model, to figure out, like, okay, so what are the holes in our, our defenses, and how can we plug them?
Yeah, this is the real interesting. Like when you mentioned Shopify and their like how did you say, like their client companies? Because funnily enough, like like from WebAssembly plugin perspective, like Shopify's users are the companies that they collaborate with, right? Like the companies that use Shopify's infrastructure for their like selling products or like web shop needs. And like this is a really interesting distinction, but also like consideration. Like what, well, like people keep saying, oh, WebAssembly is safe and secure and whatnot, but like what is it safe from, or like what do you secure WebAssembly against, right? And like
Right.
there's all these like words thrown around. It's like, but and without the understanding of like the underlying technology and like how that technology, what kind of guarantees that technology makes, right?
Right.
It's really hard to kind of grasp like what do we mean when we say like WebAssembly is safe, or like safer than doing X or Y. And like as always, like this kind of like safety or like security should be approached from like a perspective of like a threat modeling, which is um, sort of like just like like what should be the kind of threats that we are, or like the security problems or security issues that we are trying to defend against in the first place. And like a lot depends on like basically who supplies the WebAssembly code, and like who deploys the WebAssembly, who's going to run the WebAssembly code. And something really interesting about WebAssembly is like it was kind of intended for like a very hostile and very unforgiving like kind of uh, ecosystem, or like environment, which is the browser itself, right? Like somebody writes some code on the internet, like deploys it onto a server, and your computer downloads their code and runs it on your computer, right? So it's like the web browser runs that code in your computer, in your web browser, and like potentially even like other websites like download this code, or like there's like all kinds of interactivity between. And like the web's threat model is like really like just protecting the user at all costs, right? Like they call the web browser a user agent because it kind of acts on behalf of the user, and it kind of tries to protect you on your journey on the internet. And
Right.
like that's kind of like the ecosystem, or like the environment that gave birth to WebAssembly. So it was like that, like it was in its like history, or like kind of in its DNA, to be built in a way that actively makes it able to like kind of resist like hostile environments, or like be able to be used in hostile environments. And so we take like WebAssembly and put it into various places, and then that kind of environment changes. Probably the hostility like remains a lot of the times again, but like maybe it's changes like what kind of issues that we are kind of worried about, or like kind of what you're trying to be looking for. And sometimes we even want to relax the security sandbox when we have things like like we want to be able to access like some kinds of external data or API, WebAssembly itself can't really do anything. So Shopify wouldn't be giving it like the WebAssembly code you're deploying access to some APIs or some imports or some like data about the checkout or something. You couldn't, like, your code couldn't do anything, right? So they still have to do that. Like they still have to kind of loosen the sandbox in a way and give access to like the WebAssembly code to some things that you will have to really like think twice, like what kind of access you're going to be giving this WebAssembly code, and like how is that like data, or how is that like API can be exploited by the code. And there's another things like like denial of service attacks. Like what if you deploy a plugin into, for example, like staying with Shopify's involved, like Shopify's infrastructure, that just tries to overtake the whole system and just consume all the resources, like consume all the memory, consume all the CPU, like like a bit like an infinite loop of sorts. And like if they haven't made the necessary like precautions in the runtime that runs your WebAssembly code and the server that runs your WebAssembly plugins, that could also cause a lot of issues. And so it's very imperative like that we think about what sort of like issues could happen when running like third party like code like this. And if you think about it, like for example, there are companies, or there are like startups that experiment with like giving you the ability of like running WebAssembly based plugins, for example, like a text editor, or like even like more complex software. Like if you just write yourself a WebAssembly plugin for your own editor, like you really are not concerned with like security, right? Like that's I've wrote like this thing for my own for my own like text editor, so it can like do like weird like capitalizing of like sentences, or like inserting two spaces after every like period or something like that. And like I can customize my editor using this WebAssembly based plugin that I wrote myself. And like obviously you're not really concerned about somebody trying to steal your apes or cryptocurrency or whatever from your computer, or like credentials of like a different computer. But like what happens when you want to, for example, the text editor has a marketplace, right? And so you want to share your amazing plugin to improve everybody else's lives, and like
Right.
like have their periods, all the spaces that they need, and like you could publish basically this WebAssembly module into a marketplace. But then at that point it becomes like a really important thing. Whether your WebAssembly plugin has like some denial of service, or like encrypts your hard drive, or eats your laundry. Like at that point it's important to make sure that that WebAssembly module only has access to things that it needs to have access
Right.
to, like has only the permissions that it needs to have permissions to write. Like if you write a plugin in WebAssembly for a text editor that's supposed to be able to read your text and like replace in places where there is only like one space after a period, like with two spaces, like full stop, uh, then you don't need that WebAssembly module to have access to your file system to be able to encrypt your files and then, like kind of blackmail you for like a ransom. On the other hand, it can still read all your documents, right? So, like you probably shouldn't put sensitive data into there, because and like, like maybe that WebAssembly module sneakily asks for permissions to be able to make outside like requests to a web page. And then it can like exfiltrate your data from your text editor and like send it to an external server. So again, you should make sure that like the the WebAssembly plugin itself has only like the given
Mm-hmm.
permissions. But then, like this gets pretty hard at some point, all right? You're like, okay, I don't give it any access, like it definitely cannot exfiltrate my data. And then the WebAssembly module just like does like a, like a infinite loop, and like kind of takes over, like because of like the architecture of the application, like just takes down the whole text editor and loses your loses your like content or like information, or like takes down your entire computer because it's just like your operating system crashes. And like that's really hard to defend against. It's like that like halting problem is a thing. Like halting problem is like you can't actually tell about a computer program whether like the computer program is going to stop. So like you can't, but basically you can't, yeah, like detect infinite loops in a computer program just by looking at the computer program. And so like if you don't defend against this issue, like you can't just say, like we don't give you permission to hog all the resources of the computer. Like you can do something like, ensure that like lower level, like like only certain amount of processing power could be used by this WebAssembly module, which is actually really interesting because it's very connected, or like the whole concept like comes up more and more the moment you kind of delegate like information or delegate computation to like plugins or like extensions in WebAssembly. And it actually has been explored by a lot by exactly the cryptocurrencies that I've been mentioning earlier, like cryptocurrencies and like internet computers that run on like blockchain networks and stuff, like running into the same exact problem of like kind of like incentives, right? It's like it's not your computer. Like the internet computer literally runs on like millions of people's machines, distributed. But then it's like you're not paying for the electricity of that other person. So how do you ensure that you're not like taking like an undue share of resources? Like how do you ensure that your code actually runs like as lean as possible? And so a lot of cryptocurrencies have some sort of like approach to amount to like they a lot of the time they call this fuel or like kind of gas or like something like that. It's like kind of you pay for a certain amount of like fuel to like or like prepaid electricity of sorts, or like prepaid computation. And if your code takes longer to execute, then it will like fail to run. Like this is how they kind of like defend against like the halting problem, for example. A lot of the times, like like computers just like you probably have seen this, like when your web browser said, "Hey, this script is making your web page slow." What happens there is like there's a JavaScript that is like kind of hogging resources, and your computer can only say, I don't know what this script is doing, but it's been doing really hard for 10 seconds, like crunching numbers, and it might be completely legit. This might be something you want to do, but also like there's a chance that this thing just like crashed, and like like you might actually want to stop like it, but like it cannot tell, and like it kind of like refers back to like you making the final decision. And this becomes like an actual big problem in like a lot of these extensibility scenarios. If like I'm taking external unverified code, uh, if you are taking external unverified code, and like how do you figure out how to make that safe, but also how to make that like kind of efficient? Like how do you make sure that it actually doesn't like somebody is not mining like cryptocurrencies, just to stick with the cryptocurrency alternative. Somebody is not mining cryptocurrencies using your infrastructure to like generate revenue, like or like misusing your infrastructure in other ways. Like how do you actually do that? It's like a recurring problem and like a recurring issue, not just like the WebAssembly sort of like WebAssembly sort of like extensibility, but even before, right? There's like extensions in my software. Like, how do I ensure that they play nice?
Mhm.
It has been like an ongoing issue that
Mhm.
some of which actually WebAssembly can fix, but like not
Right.
everything.
Because there are bidirectional trust incentives
Yeah.
using WebAssembly, right?
Yeah, absolutely. And so this is like really interesting about like WebAssembly and like just a lot of like I talked a bunch about like cryptocurrencies, but just generally the kind of distributed, decentralized kind of way of thinking
Mhm.
uh, is like, like what incentives are at play and like what kind of like uh, what what kind of like trust relationship happen, like what, the intents, the incentives themselves are kind of affect, how like the trust in the whole system, and like
Mhm.
where do we actually move the trust, like, ooh, somebody is ringing, like where do we move those like incentives, where do we move these where do we place our trust, and how do we incentivize players to not, against misuse of our systems, and like against
Mhm.
playing, nice. Like this is a lot of like social and like engineering and like a
Right.
lot of things that has nothing to do with like computer systems in a way. uh like even like this is really, I don't think many people actually know like what we like a lot of people like a lot of the industry like complains a lot about like blockchains that use proof of work as a technology to kind of sidestep this trust scenario or like align incentives. Proof of work is basically doing some mathematically provably hard computation that's easy to verify but hard to do, and like kind of use that as like a kind of disincentivizing like people to kind of like spamming systems or something like that, or
Mhm.
like ensuring that something happened. And like a lot of people don't know that this whole idea actually like originates from, or like goes back to way before like the blockchains, and like actually people
Mhm.
are thinking about, oh, maybe we could use like some sort of technology like this to disincentivize spamming, like email spam. Like how about like people have been thinking about like, like what if we create like a stamp, like a digital stamp that you have to pay for your emails that are sent and like stuff like that.
Mhm.
And like the people are like, but like what's the point, the point of email is like kind of there's no barrier of entry. And then the people came up with this is like kind of try to disincentivize, raise the marginal cost of sending an email by
Mhm.
requiring that you do some like kind of expensive computation, which is not expensive in terms, it's expensive in terms of like a couple cents of energy, right, or like electricity. And
Mhm.
like if you send like 50 emails a day, like nobody cares about like that and electricity that your email client uses. But if somebody wants to spam a million email addresses, it actually adds up. So,
Mhm.
and like a lot of people don't really know that this goes all the way back to like trust issues. Like we have the original trust issue of like email spam to this day.
Mhm.
And like those trust issues are like socio like economical like kind of issues like have not disappeared. Like a lot of the systems, like especially like systems that like rely on like multiple untrusting parties still exist, and like cryptography is like helping in some part of it, like but like socio-economical processes are at work that we need to understand, and we need to kind of use to align the incentives to do here. And like WebAssembly can help with some of this stuff, but like inherently is not unable to solve like social problems. Like most
Right.
technology is not never gonna solve social problems. But yeah, that's like a really
That's why we
interesting
still
thing
need the
that
humanities.
I guess, yeah, some we still need people to, and like a lot of the time, you can go back to like Greek philosophers. It's like, yeah, they already thought about this, and it's like a hard computer problem because it's not a computer problem.
Right. Yep. Yeah. And so the fact that WebAssembly modules can be made so very small, makes them have, the smaller, attack surface, so that then that is sort of an extra, not layer, but another characteristic of WebAssembly that lends itself so well to greater security, if I understand correctly.
Yeah. I mean, in fact, like this kind of goes back to what I just mentioned. Is like WebAssembly itself, like is like has this like multiple properties kind of like needed together in this
Mm-hmm.
one like whole, and like most like all of these properties of like doing some heavy lifting and like making sure that the technology can actually achieve like kind of some of the promises that it does. And so like the size of WebAssembly stems from a multiple sources, right? Like WebAssembly itself is like kind of like a binary uh, like a binary instruction set sort of thing. Like it's a binary bytecode sort of thing, like the WebAssembly binaries themselves. Which means that like they contain a binary code or binary instructions for like a sort of like virtual machine, like a virtual processor of sorts. And like the WebAssembly instruction set, like that number of different instructions this virtual CPU or virtual computer can handle is pretty limited. Like it's a very like mm, uh, like limited like amount of like different instructions exist in the first place. So, of course, like some like WebAssembly is getting new instructions as new features are being like developed, but that already makes this sort of like computer code that generates like this binary code that WebAssembly generates pretty compact in itself, and like a lot of the times people are actually using a very low level programming languages that are very well optimized. So the WebAssembly code output of these programming languages like Rust or like even C++ or C are can be really actually pretty small. Not as small as as like a five-line JavaScript code, but it's still a matter of kilobytes or something like that. And so compared to something like a executable program, like some of the applications you download to your phone or like to your computer are like hundreds of megabytes. Even if like a lot of the if we speak in cloud terms, like a lot of the containers that you like kind of like package a web application or a server into like can be like multiple tens of megabytes or even hundreds of megabytes. And like a WebAssembly module, like by comparison, like our friends at Fermion, like they released a WebAssembly module that is a complete web server in 250 kilobytes of WebAssembly. So like orders of magnitude smaller than like comparable like software. And so that kind of like when you get like to those sizes, like it matters. Like it matters because like we talk a lot about like deploying WebAssembly on the cloud, and like there are companies already deploying WebAssembly on their international global edge network, which is like multiple hundreds of computers like around the globe. And so you can deploy a WebAssembly function or like deploy this like functionality, and it gets distributed in a matter of seconds around the world into like computers like from New Zealand to like I don't know like Chile. Um, and like they have multiple hundreds of servers and like multiple hundreds of thousands of users like deploying code into these servers. And so first of all that when you deploy the code, you want it to be available everywhere as soon as possible, right? You don't want
Right.
your code to be updated in one part of the world but the other part of the world it only like this inconsistency could like lead to really big problems. So it's in their very best interest to make like these deployments really fast, which helps if you're the thing you need to transmit over like vast distances of like international networks. is like 200 kilobytes in size and not like hundreds of megabytes. But also like those computers need to store hundreds or hundreds of thousands of these like modules from all their users of the company. And so, it doesn't matter, how small or big the module is, like, for storage space. And then, you need to, like, a lot of these companies, like we keep talking about WebAssembly cold start times as being a cool thing. Like, as like WebAssembly, you could just like instantiate in microseconds and like run the thing, learn the code contained in this WebAssembly module, and just throw it away and just start again like the next time you need it, which is pretty amazing. But it also, like, like SSDs and like computer like storage is like really fast today, but like it does matter, how long it is going to take for the computer to load that WebAssembly code into memory, and then it still has to do some compilation. The runtime still does like the translation of the WebAssembly code to the native machine code. So like there still needs to, as the longer, the bigger the code is, the longer time it's going to take to translate. So like there's all these like sorts of like things which like just instantly, oh yeah, yeah, give your code like a kind of a diet, reduce it tenfold size, and all these amazing like opportunities just kind of fall out of it, being like, a couple hundred kilobytes. It's like it runs fast, and it's like transmits fast, it's deploy fast, and like it's resource unintensive, right? Like it's a 200 kilobytes of like code, like you compile that to machine code, it's not going to be a whole lot bigger, but like, a couple hundred kilobytes of code in the computer memory. And so you have this server that can run thousands of these, like in like a couple gigabytes of memory. So like just like the resource efficiency that WebAssembly makes kind of possible, is like really important. And actually, I think you and Sol actually talked about this in terms of uh, uh, how small can it be? And the problem is, like, a lot of the times you can't make it actually this small because you need some really interesting functionality. And like, you need some kind of dictionary, you need some kind of like really sophisticated algorithm, for example, to turn, like for word stemming. Like imagine your WebAssembly does kind of like full text search, and you want your WebAssembly to be able to, understand, like all the different versions and like different versions of like a word. So when you search for like, uh, modules, it will also search for module, like the singular form, and not just the plural form, or one the other way around. And so like a lot of the times, like you can build some stemming algorithms that can like kind of catch a lot of these. But also like sometimes you just need a lot of data because you need like an actual dictionary with like all the things that cannot be like algorithmized, like just the exceptions and stuff like that. And so you end up bundling a whole library, a computer library, like like a C++ or Rust library, to do exactly that. And like, poof, your WebAssembly module was going from 200 kilobytes to like a 1 megabyte. Or like the same, like a regular expression engine, same story. Like a lot of the times, like because WebAssembly doesn't have access to anything, like you kind of have to start from scratch. And so it's actually interesting, like what can be provided by the provider. And I think you have been talking about this with Saul, is like if you could pass in like a like a regex engine that you could use, that you wouldn't have to like bundle that into your application. Like you just use this for external. And this is not a new idea. Like programming languages have a standard library that is basically like based on this kind of idea. What happens in like most programming languages, like C and C++, like closer to the metal, the standard library actually gets compiled into the program itself. More interestingly, like in a bunch of other programming languages, like for example JavaScript, some of these functionality gets provided by APIs of the browser. So the browser has this functionality. So there's no compilation needed that will bloat your program code. But like sometimes when functionality missing from the browser, people do implement it like they call it userland. They do implement it in JavaScript, and then you do have to bundle that extra megabyte of JavaScript, and that is that is absolutely slowing down your application.
Mhm.
So we're kind of like like WebAssembly is like this very new technology, but like the problems and like the kind of constraints it faces is like not unknown to like the ecosystem like computers. Like a lot of
Right.
this actually things like do actually exist in WebAssembly, but like like making incremental improvements or making it easier to kind of tackle these issues in the future, because of like how like kind of WebAssembly was like kind of built from the ground up, and like some of these like future issues were well known, so we could kind
Mhm.
of build WebAssembly in a way that is going to make it a slight bit easier to tackle some of these issues. You can already
Right.
kind of see
Right.
that happening.
Yeah. I mean, and that kind of thing is sort of a problem. I mean, completely outside of computation, right? It's a problem like in life. If you can, like, if you're traveling somewhere, the
Hmm.
more you have to actually bring with you, the harder and longer it takes to get there. But if you know that when you get there, you're going to have a kitchen, say,
Yeah,
then you don't have to
yeah.
bring your food and all of your cooking utensils and all of that stuff because you can use it when you arrive. And that's sort of how I think about. I hope that that's a reasonable
That is
analogy.
100% perfectly analogy, and also hits very close to home. Like looking at my giant bags that I keep lugging around for the past month. So
Right. Yeah. And then that leads to um alternatives like if we've got embedded scripting for like Lua and JavaScript, and we've got all this language extensibility now with where that's sort of extending WebAssembly itself, as opposed to other instances where it's like WebAssembly is extending other things. We're extending WebAssembly itself by being able to communicate with WebAssembly in all these different languages, sort of a come as you are kind
yeah.
of kind of philosophy. We're not quite there, but we're getting closer and closer and closer.
Yeah, I mean, like this is what I mentioned to you is like kind of WebAssembly is super uh like bare bones, I would say. Like it's called an MVP for a reason. We just had like people talking about like WebAssembly 2.0 coming. Uh, yeah. So yeah, WebAssembly has been kind of starting off like really like low key and like kind of the uncontroversial ideas got implemented first, but a lot of the upcoming stuff is going to like make it a lot more of a powerful language. Um, and so this is actually like a really important point in terms of like what's coming in the really near future. Yeah, like WebAssembly 2.0 is absolutely one of those. Like a lot of people are like, including myself, are surprised like, wait, WebAssembly 2.0, what is that?
Yeah, this is the
But like,
first I've heard of it.
yeah, WebAssembly 2.0 is basically so when WebAssembly got released, they're like, hey, this is WebAssembly. We call it an MVP, like a kind of minimal viable WebAssembly. And like it can do a couple of things, but like there's not a whole lot of like power built into it. But we're like, we have a lot of ideas about like what other things we want to make happen, but they were like, um, but they're not quite there yet, and we didn't really don't want to rush it. We also kind of want to get like this minimal viable WebAssembly out to people, so they actually get to experiment and like, give us feedback. So we
Mhm.
know what to implement and like give to people. But like what it set it up is like we have all these technologies like kind of still brewing, and
Mhm.
slowly those technologies like started landing. Like a lot of the probably SIMD is one of the most well-known technologies that is now included in WebAssembly 2.0. That is the single instruction multiple data or like kind of vector instructions. The short version of like what this is like a lot of CPUs, like a lot of processors, like computer processors since like the 90s, like this is like really old technology, are able to do something like you can tell them add 1 plus 2 equals 3, but you can also say here's a array, here's a vector of like 4 numbers, like 1, 2, 3, 4, and like add these 4 numbers to this other 4 numbers, like 9, 8, 7, 6. And like, like instead of like doing them one by one and like writing the result into like, like giving back the result, the CPU would execute this like addition like as a vector, or like on all numbers in like one cycle, or like one instruction. And so like, like a lot of the times this is not useful when like you have dependencies and like the data, like the second number or the second calculation depends on the result of the first calculation. But a lot of the times you have algorithms that are very easily parallelizable. So imagine like image manipulation is like exactly that sort of thing. Like you want to reduce, like for example, the brightness of like an image. Like you basically take the image and like take all the components, the color components of like the red, green, and blue components, and like reduce them with like a given amount, or like make some transformation on them. And so you can do this one by one, but like if you could do this like 1 pixel at a time, or like even like 1/4 at a time, like if you just treat the numbers, if you can treat the number itself as like a 32-bit number, for example, like you can like immensely like speed up computation. And so this feature has been like in the works for some time, like implementing WebAssembly to be able to support these instructions, but it just wasn't ready in time. And so when like people managed to actually come up with the right ideas and like standardize this like WebAssembly, they started like the standardization process instead it itself relies on like actual implementation. So when the standardization process looks good enough, like here's how it's going to look like, when people agree on it, like people are expected to start implementing it. So issues from implementation could also, in the last moment, like could still affect like the standardization process. So we don't standardize something that is like turns out to be like a really bad idea, and like we'll have to live with it because it's all set in stone. But by the end of this whole process, like the feature is pretty much like everywhere. Like most of the WebAssembly runtimes on the web, and like in like in CLI tools, or like libraries that like we use, for example, as some work tool. Like most of those tools already support SIMD instructions. But SIMD instructions are just like a sort of extension to WebAssembly MVP. So like the WebAssembly like standardization committee kind of decided to make this as like a, we could call it, WebAssembly 2.0. It has all these features, and like that's part of WebAssembly now. Like if you are supporting WebAssembly 2.0, that means you support these features, or you want, you can make sense of those features at least. So that's what's happening. But like a lot of the features, the defining features that are still not part of WebAssembly 2.0, or like still not released or like ready in the same way. And one of those is actually like this easier interoperation or collaboration of WebAssembly modules. There are multiple facets of it, and multiple things that this makes possible. Probably the nano process model is one of the most like thorough explanation of where the WebAssembly ecosystem is trying to get to with this. But like the idea is like instead of having to pack your application to a single giant WebAssembly module, you would just have small, tiny modules, like kind of like the, how's it called? Like the monolith versus microservices model. Like kind of instead of like building the computer code into a single giant WebAssembly application, and then being this big monolith application, you kind of just like build your application from collaborating modules, doing one thing and one thing right. And like, so you, instead of building a regular expression engine into your application, you could just use a regular expression WebAssembly module, like that is dedicated for running regular expressions, has some sort of API, some imports that you can import from it into your application, and then just use these WebAssembly code, this WebAssembly code to like kind of like take advantage of that facility. And the good thing, like the good useful thing of that is, of course, like sometimes your runtime can provide some of these. So instead of you having to deploy and use like two modules, one your application and one your like regex module, like the WebAssembly like runtime that you're using could provide you like a regex module, so that they wouldn't end up like 100 modules, each bundling its own slightly different, slightly unique, like regular expression engine, hogging memory and compilation time, again bloating the size of the binary, right, and like losing all those benefits that was before.
Yeah.
So that's absolutely one of the things that new features in WebAssembly technology is like improving constantly on the ecosystem and like making this it more viable. Like this is important for both from like an infrastructure point of view. This is important from a developer experience point of view, right? It's like if you can just use these things instead of having to find your own and figure out your own. And like as you mentioned, like we talked a lot about WebAssembly, like kind of not the first thing that figure out that it could do things like embedded into your applications. Like there were like a lot of other, I guess you could call them like precursors to like how people embedded user-defined code in their applications. Like a lot of game engines, for example, provide some sort of scripting opportunity. Like, they will give you an opportunity to make some script and use some scripting language to make something happen when some event happens in the game, or like something like that, or like some reaction. But like a lot of other tools, like plugins have been a thing for ages, right? Like not just in text editors, and like there's a lot of like software that you can extend with like extensions. And there has existed ways, like be that JavaScript or like Lua was, for example, like a really predominant language when it came to like embedding into like a software to provide like scripting possibilities. Because primarily, like it's interesting, like Lua was like easy to grasp. It's kind of this JavaScripty language if you never used it. So it's like a very easy, like kind of easy to get started and grok like script language. That also, like the runtime of the language was like a couple hundred kilobytes. Like it was just a C library of like a couple hundred kilobytes that you could embed into your application, and you would have like full, like Lua support and the whole full power of the language. And like it's been used for a lot of extensibility of a lot of software, but like there is like issues that helps, if it's like a small library, you could just easily drop into your applications, but like you still need to learn Lua, right? Like, I mean, easy or not, like it's still another language. And this is why actually JavaScript kind of won, but like JavaScript was a lot harder to embed. Like there's still, like the GNOME like windowing system in like Linux operating systems. If you're using Ubuntu, for example, like that's the default windowing system. You can actually create extensions to the GNOME like user interface in JavaScript. Like there are tools that actually use JavaScript, but it's harder to embed. Like JavaScript engines are more complex than Lua, so there was a bunch of issues from there. But people like JavaScript a bit more. Like it's a bit more prevalent than Lua. So you would kind of want to like have JavaScript and not Lua. And like Lua is kind of sort of similar, but not the same. So you still need to learn a new language. And it's also like JavaScript or Lua, there's still script languages, so they're not, the performance is not their prime characteristic. Whereas like you could do, and like the opposite, or like the other thing you could do is like binary extensions, which is like you would write a very performant extension in C or C++, and then compile it to like a DLL file or something like a in a binary format, like that would like kind of link dynamically with the application. It's really a mess, because then you compile it to machine code, so it has to you can't distribute your extension to like every architecture. You have to compile different versions of it for computers running different like architectures or operating systems. Like this is a big thing. This is a big problem in Node.js in particular. Like the binary extensions of Node.js are like a huge pain in the ass to use.
Oh.
And like and like your application runs binary code. Like sandboxing is almost non-existent in these cases. Your plugin can actually bring down the entire application. This actually happened a bunch of times in browsers.
Uh-huh.
So browsers have this issue, like when like third-party code or like versions like for example crash your browser. Like you can't do anything about it because it's binary code that's running. Like it's like binary code directly running on the CPU, compiled for that CPU. There's no runtime. There's no sandboxing around this like piece of code. And at the end of the day, you still have to write it in something like a C++ or like something like low language SDK that like the language came in. And so WebAssembly is kind of like sorting out a lot of things here. It's like fast enough, like definitely faster than a scripting language, but also you don't have to use a scripting language. Like you can use C or Rust. You can also use JavaScript, like a lot of the times, like in suborbital, we are now supporting like in like JavaScript, for example, to write WebAssembly binaries, and Ruby just like published like their update on like bringing Ruby to the WebAssembly ecosystem, and Python is like becoming more and more a part of the WebAssembly ecosystem. So there's a lot bigger, selection of like what languages you use, and so it's fast enough. But there's also the sandboxing, which means like first of all, your module can only have access to the things that it should have access to, but also it cannot just like bring down the entire application when something goes wrong in your module. Like your module will fail, but like it cannot bring down the application, which is like a huge addition to one of the biggest like proponents of this like kind of use case is Envoy, which is like a um, uh, which is an application that like kind of handles ingress, like so network requests, and like it's kind of an application proxy for like cloud applications. So like manages like incoming requests and like directs it to like containers running some sort of backend software. And they used to have binary extensions, which was really important because they had to have a performant way to kind of direct all this traffic that like was like they were like a bottleneck of the entire system. So they have to be really fast. And they actually had a problem with like, yeah, you can write a performant like extensions in C++, but like the problem with them is like if something goes wrong, and like that doesn't necessarily mean like you wrote the extension wrong. Like maybe somebody feeds the extension, like feeds the like the server like malformed data or bad data that your extension chokes on. Like maybe the server wouldn't mind, but your extension just like kind of throws a fit, and it can break down the entire server, which is responsible for the entire application. So it's like a giant issue of like like for example, if somebody finds like some input that you can like reliably crash a plugin, then you found the DDoS like a DDoS opportunity practically. So like that can become like a really that can be a really huge issue. And so they actually ended up switching to WebAssembly, where yeah. Yeah, so they ended up switching to WebAssembly for their plugin system, and like basically like developer productivity and like everything. They have a blog post about this that is like really like detailed and like a very good
Mm,
example of like what you gain from WebAssembly when you're switching over from binary files. But like the number one issue or the number one positive outcome of that was actually, well, now your plugin cannot crash the Envoy server. Your
right.
plugin will crash, and the server will happily ever after just go on. Like that was one of the things. It's like your plugin, has like less. You have to worry about your plugin less.
Right.
That's really useful.
Yeah. I mean, I guess, and we just have a few minutes left, I think. So maybe we could
Mhm.
hear a little bit more about some of those plugins like Figma and Microsoft Flight Simulator.
Oh yeah, yeah. So I mean, that kind of. Uh, this is still a budding ecosystem. There's not a whole lot of things happening. Uh, there's not a whole lot of things that are using like WebAssembly based
Hmm.
plugin systems like out of the box yet. But it is kind of still like a emerging like kind of idea, and there are
Hmm.
already some experimentation that and some things that already support these WebAssembly based plugins. As you mentioned, probably one of the most well known or like most used ones beyond Shopify, which we already talked about, is probably Figma. The interesting thing about Figma is that their plugin system, they really wanted to use JavaScript and uh, and and so the for the plugin system, they really wanted to use JavaScript. But the problem is like using JavaScript in the browser, because Figma is a browser application, and they already been
Hmm.
using WebAssembly. But they're like, okay, but we now kind of want sandboxing. Uh, like we want to sandbox these plugins, but like we kind of want them to run JavaScript. Like we can't have them run WebAssembly, like straight WebAssembly. We kind of want
Hmm.
the users to be able to write their plugins in JavaScript. And so
Right.
they ended up basically with the same concept or like the same idea that we are using at Supportable and Shopify uses for running JavaScript inside WebAssembly, which is using
That's
a
how you know
particular.
you're on the right track when everybody has the same idea.
I mean, we are all standing on the shoulders of giants, so
Mhm.
so there's that. But like, yeah, it's really like they kind of explored other avenues. Uh, they kind of explored other avenues to like kind of embed like JavaScript stuff sandboxed into like another JavaScript page.
Mhm.
The interesting thing, you can totally do that like in JavaScript. Like the browser, as I mentioned, is a very hostile environment. So like you put
Right.
something in an iframe, it's sandbox. But the problem is like the moment you sandbox it in an iframe, you have to transfer the data to and for. Um, uh, so you have to kind of use this like contrived mechanisms that were intended to separate very hostile sites from like different websites should be not have any connection to each other. And so
Mhm.
now you are trying to kind of not entirely hostile sites. So like we are running like unverified code, but we still kind of want to supply it data so it can like crunch. Like some Figma files could be pretty big, and like so they want to like transfer over the data in the Figma file so your plugin can operate on it. And so it was
Mhm.
just slow. It was just literally that. It's like really slow to do that. While WebAssembly kind of has like this, the sandboxing in WebAssembly is built in a way that there is a much more performant way to kind of transfer document information between the two.
Mhm.
And so that kind of ended up being a really useful like approach that they ended up using later on for WebAssembly for. But there
Mhm.
are a bunch of others, like there are text editors, as I mentioned, that kind of have like these plugin systems that they're working on.
Right.
But like even like something that you mentioned is other more commercial commercial tools are starting to have started to kind of discover like the use case of WebAssembly for this, and like
Right.
flight simulator is a good example of that. It's like they're like, we have these binary extensions, like they're a pain in the butt, and like you can't really use just like only one language for it. So how about
Hmm.
we actually make WebAssembly and like just let you do like all this stuff in like whatever language WebAssembly supports, and like kind of gain
Right.
a bunch of stuff out of it. So yeah, there's like really promising like experiments and like use cases for this, and hopefully we'll see a lot more coming. You can definitely see this being a more and more accepted or more and more uh, proven or like experimented with like technology space and like the
Hmm.
extension space, which is why I was telling people like I think it's like one of the most exciting things.
Yeah. Yeah. That's, I mean, especially hearing also about WebAssembly 2.0. So many, and reading the Bytecode Alliance blog post about the nano processes was really exciting, because something you and I have talked about is like maybe in future it could be kind of Scratch like, where you can just grab all your little bits of things, and you don't even, I mean, never mind just all the language flexibility, coding language flexibility, but what if it could be like low or almost no code, and that
Yeah,
would
that is
be
that is
amazingly democratic.
yeah, that is one big promise of like the whole nano processes and like the WebAssembly like types and like model like a lot of the upcoming like kind of improvements moving towards just nano processes kind of ideal is basically that idealistic view of like componentization, of like idealistic view of
Hmm.
like breaking down programs into like this like self-sufficient and like reusable bits, and like wiring them together, just like using them as like that, and then again just putting like a facade of like a scratch like user interface in front would exactly give you exactly that kind of idea, like whether the backend or like
Hmm.
the business logic or the logic itself is written in like small
Right.
tiny WebAssembly modules, and you could just like almost like to the point when you're like wiring them together like you do in like audio visualization software, like when you have like these
Hmm.
inputs and outputs and like just plugging those together, like kind of the same idea of like this low code like kind of perspective, which is like wiring these components together that have
Right.
like a shared API boundary, and like could be written in any language. Like a Rust module could be communicating to a JavaScript one, and like
Right.
you could use the language that would be the best fit for your skills, or
Hmm.
it's really exciting, and it's
Yeah.
getting closer and closer. So we can only it's only a couple. Well, we don't have to hold our breath for too much longer, hopefully, to start
Yeah.
experiencing that unfold.
Yeah. It's a super exciting time to be joining the WebAssembly community, I feel like.
Oh yeah, I concur. Like the best time was like 6 years ago, and second best time is now.
Yeah. Yeah. Well, thank you so much, Flaki. This has been so interesting and informative.
Oh yeah, I hope you enjoyed it. I hope it was useful for people, like kind of getting
Definitely.
a glimpse of the extensibility ecosystem, and looking
Hmm.
for like be sure to look forward to the blog post coming out of this on the dovetails of this conversation.
Right. Right. Yeah. And
Thank you
thanks
so
to
much.
Ramon for moderating today and hanging out in the chat.
Yeah, thank you.
Mhm.
Or little like
Right.
back end like shadows lurking in the shadows, like helping. Yeah. No, thank you so much
Yeah.
for joining me today.
Yes.
I'll hope you see you next time for some
Yep.
interesting
See
other
you around
topics.
soon.
All
Thanks.
right. Bye, y'all.
Bye.